Okie dokie. In this problem, they say the temperature of a chemical reaction oscillates regularly and symmetrically. The lowest temperature is 30 degrees at time 0 hours, and the highest is 90 degrees. If for t greater than 0, the temperature 30 is reached for the third time at 72 hours, what is the period for this function? So the idea with this question is we are going to create a sketch of this graph, and we are going to find the period of this function, which is basically the amount of time it takes for it to complete one cycle. And so one cycle means if we have a squiggly function like this, one cycle would be, say, from here to here. It's the time it takes to start at one point, go down, come back up, and reach that same exact point. Okay? Okay. So, starting with what we know the lowest temperature is 30 and the highest is 90, meaning if the lowest is 30 and the highest is 90, then its sort of midline will be 60 because it's going to oscillate symmetrically. Okay, so we're starting at the lowest temperature of 30 at time 0, and all it says is that at 72 hours, it has reached 30 it says 30 is reached for the third time. So I'm assuming, let's see if I can get this right here. So for time values greater than 0, 30 is reached for the third time. So they're not counting this as one of those three. They're saying after 0, it hits 3 more times at a temperature of 30. So 3 more times it reaches 30. So we're going to say here, here, and here, right? All right, so we have that, and then from there, I think we can just create a graph. So it's going to go up. It's probably going to hit 90 about halfway, so we're going to do something like this, and then this, and then this, and then this, and this, and that. All right, little wobbly, but that's okay. What is the period for this function? Clearly, we can see a period length by looking from here to here, okay? Or from here to here, or from here to here. What do we have? We have 1, 2, 3, three perfectly spaced sort of intervals from 0 to 72. So if we take 72 and divide it by 3, we will get the length or the time for one of these periods. 72 divided by 3 is 24. So I'm hoping that that is our period. That's it. All right. Hope that made some sense. Let's see if we can do it a little bit faster here. All right. Same deal. Lowest temperature is 70. The highest is 100. So I'm going to move this bar down here. Let's see if we can do this. Boom. All right, so the lowest is, what do we say, 70, the highest is 100. So we're going 70, we're going 100. I'm just going to spread it out like this to make it make a little bit more sense. We're going to go halfway mark here. That's got to be 85, halfway between them, right? And then they say the lowest temperature is 70 at time 0, blah, 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 blah. The temperature 85 is reached for the second time at time 15/8 hours. Okay, interesting. So 15/8 hours. We're going to go ahead and throw that. Where should we throw that? Dang, I don't know. Maybe we'll just throw it out here. 15/8. We'll see how lucky we get with that. I'm not so sure about that, but we'll see. So the lowest temperature is 70 at the start. Okay. And the highest is 100, and it reaches 85 for the second time at that value. Okay, so what that means is I'm going to back this thing up. 15/8. I'm just going to throw it right here so that I can show you what's about to happen here. Because if it goes up and, let's see, for t, reaches for the second, yeah, okay. So it's going to reach 85 probably, I mean, definitely here at 15/8, but since it's reaching it for the second time, that means it must have crossed over to begin with. Since it's starting at 70, it goes up, hits 100, comes back down, and we haven't even gone a full period yet. So this is where it gets a little tricky because it comes back down, right, and then hits the minimum of 70 again. So if we can figure out what this distance is from start to finish here, we have 1 period. But all we know is really the distance of, I guess you could call it 3/4 of a total period, right? Because it's 1, 2, 3 of the total 4 out of 4 that makes up the period. So you can kind of section this off into like 4 equal points, or 4 equal segments, I guess, that make up the entire period. So if we know that 3/4 of the period equals 15/8, we should just be able to solve for p here, like it, like we're solving for x, and we'll get the period. Okay, let's try that. So how do we get p by itself? We get p by itself by dividing by 3/4, but that's the same thing as multiplying by 4/3. So if we multiply this by 4/3, we get p is equal to this. Lovely, right? Let's simplify it. We get 15 divided by 3 is equal to 5. And then 4/8 is equal to 1/2. So I'm going to go with, 5 times 1/2, or 5/2. Hope that made a little bit of sense. This simplified to 5/1, then this simplified to 1/2. So we're left with just 5/2. And I'm going to go with 5/2 hours. That was pretty fun, right? A little bit trickier. Let's see if we have time for one more here. So lowest temperature is 20 and the highest is 80. Let's move this bar down again. Did not prepare for this. So 20 and then 80. So halfway between, what would that be, 50? So 50 is our halfway. Hits 20 at the lowest. So 20 at the start, I mean. And then temperature 50 is reached for the 3rd time at 25/8. So hopefully if it reaches it for the 3rd time, that means we'll at least have 1 full period, before the 3rd time, right? So we have 3rd time, and we'll just go evenly spaced from there. We need just 2 more. So bam, bam, and bam. It was a little rough, but you get the idea. So it goes up, hits that, comes back down, hits the low point, and then goes back up. So we have at least 1 full period from here to here. So we just need to figure out how far apart that is. We can kind of use that same trick where we can count the number of like quarter periods we have. We have 1 quarter period, 2 quarter periods, 3 quarter periods, 4 quarter periods, and 5 quarter periods. So you take a period and you can break it up into 4 even spaces every time, like that. So what we have is 1, 2, 3, 4, 5 quarter periods. So 5/4, 5 quarters of a period. And we know that 5 quarters of a period is equal to 25/8. And so if we want to solve for p, we're going to multiply by 4/5 on both sides, canceling this, leaving us with p is equal to, let's try this again, 25/5 is equal to 5, and 4/8 is equal to 1/2. So 5/2, once again, I believe, is our period. That's option D. We break out the eraser to see that D is our answer. Very long video. I apologize. I hope this makes a little bit of sense. This was just one way of going about it. I guess, like, well, I would say graph it every time, but the ways I was going about it might have, you could probably do it in slightly different ways. So anyway, if you have a better way of doing it, let me know, and I'll, entertain that, and I'd be happy to maybe work out a different video showing that method. Okay. All right. Bye-bye.